Welcome to Get Your FRQ On. This question is from 2026. It's question 5, and it is not calculator active. In the question stem, we've got a remote controlled toy car moving back and forth along a straight path, and its velocity at time t is given by a function v, which is a piecewise function, and that function is provided. V of t is measured in feet per second, and t is measured in seconds. We are also provided with a graph for v of t. In part A of this question, we are asked to find the acceleration of the car at time t equals 1 second and to show the work that leads to our answer. Because v of t is a piecewise function, we have to identify the part of v of t for which t equals 1 is in the domain. For that part, we're going to find the derivative of v prime of t, and then we're going to evaluate it at t equals 1. And for that part of the piecewise function, we get v prime of t equals 4 times t cubed minus 24t squared plus 32t. Using v prime of t, we get v prime of 1 equals 4 minus 24 plus 32, which is positive 12. So the acceleration of the car at t equals 1 seconds is 12 feet per second per second. In part B of the question, we are asked if the car is speeding up or slowing down at t equals 1 second, and to provide a reason. We saw earlier that v prime of 1 is equal to 12, and we note that that is greater than 0. If we evaluate the function v of t at t equals 1, we get positive 9. That is also greater than 0. Because both v of t and v prime of t are positive when t is equal to 1, we can conclude that the car is speeding up at t equals 1 second. In part C of this question, we are asked to find the distance traveled by the remote control car on the closed interval from 0 to 4 and to show our work. It's worth noting here that since v of t is never negative on the interval from 0 to 4, the distance traveled is equal to the displacement on that interval. We're not going to have to worry about absolute value here. So to find the distance traveled, we're just going to integrate from 0 to 4 v of t dt, which is the integral from 0 to 4 of t to the fourth minus 8t cubed plus 16t squared dt, which is going to be 1/5 of t to the fifth minus 2t to the fourth plus 16 thirds t cubed, evaluated between 4 and 0. And that gets us 1,024 fifths minus 512 plus 1,024 thirds. And whatever that is, that's how many feet the remote control car traveled on the interval from 0 to 4. You don't need to simplify that. I didn't. It's not a calculator active question. It's probably not worth the trouble. So once you have something you can be confident is correct, just make sure you label it and leave it. In part D of this question, we are asked to find the average velocity of the car on the closed interval from 6 to 12 seconds and to show our work. The average velocity of the car on the closed interval from 6 to 12 seconds is going to be the average value of the velocity function over that interval, which would be 1/6 of the integral from 6 to 12 of v of t dt, which is 1/6 the integral from 6 to 12 of 10 times the cosine of pi thirds t minus 10 dt. So 1/6 the integral from 6 to 12 of 10 cosine pi thirds t minus 10 dt can be simplified a little bit, factor out the 10. We get 5/3 the integral from 6 to 12 of cosine pi thirds t minus 1 dt. And that is equal to 5/3 times the group, 3 over pi times the sine of pi thirds t minus t, evaluated between 12 and 6. And that is 5/3 times the group, 3 over pi times 0 minus 12, minus 3 over pi times 0 minus 6. And that will simplify to negative 10 feet per second. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.